Right. So splitting the atom. So we decided that we talked earlier on about electrons. We talked about mixtures, mixtures, elements, compounds, atoms, and molecules, and that atom comes from the Greek word atomos, which means indivisible, and that you can and and actually you can split the atom, but when you do, you imagine something like this. But in actual fact, you do split the atom all the time. What this is referring to, when we usually say splitting the atom, we mean splitting the nucleus of the atom. And the nucleus of the atom actually takes up a very, very small amount of space. So the standard analogy is if an atom was the size of a cathedral, then the nucleus would be the size of a fly. And the electrons are much tinier than that, in fact. So almost all of the atom is nothing but empty space. So let's imagine if you took Mount Everest, the largest mountain in the world, and you took all the atoms out of Mount Everest, and you got rid of all the empty space and you compacted it in, so there was no empty space. How small could you shrink Mount Everest down to, do you think? So Mount Everest would be the size of a sugar cube if you got rid of all that empty space, because atoms are almost entirely empty space, apart from the tiny little nucleus in each individual one of those atoms. So it's worth mentioning whenever you see these pictures of atoms, they're never to scale. The same with pictures of a solar system; it's never to scale. We can't draw it to scale, because if we drew the whole atom, then the nucleus would just be a dot, and the electrons would be not even visible. And the same with a solar system. So they're never to scale. Right. Right, so for those of you who didn't know what a cathedral is, it's that, and the nucleus would take up the size of a fly if it was, if the atom was blown up to the size of this cathedral. So, and if I took Mount Everest and shrunk it, got rid of all the empty space in all of the atoms, it takes much space as a sugar cube. So is there anything around in the entire universe that has matter that is so dense that a sugar cube would weigh the same amount as Mount Everest? Yes, there is, and they're called neutron stars. So let's get a picture of a neutron star. So neutron stars. Neutron stars are very, very interesting things. There's a video about them from a very good channel called Kurzgesagt. I think I'm saying it correctly. But let's go back to our picture of the atom, which I did actually have over here. So why do neutron stars behave in this way? Well, basically, because of the extreme pressure, the electrons are forced to join into the nucleus themselves. And what happens is you have a proton plus an electron, and it becomes a neutron. And so then all of the atoms are just become a big bundle of neutrons, and all the empty space is got rid of, and so you end up this extremely dense substance, which is just I guess it's just called Newton matter. It's probably got another better name than that, but anyway, it's a big massive bundle of neutrons that is like a massive nucleus of an atom, but without the protons. So that's what a neutron star is. So I'll stop the video then. What we'll do next is look at the concept of splitting the nucleus of an atom, like we were talking about. Okay.